Hi everyone, it's Mrs. Sommer here to talk about the introduction to Unit 6 and dimensional analysis. And this lesson I am seeing does not have a number. It is lesson 601C. Okay? And so we're introducing the unit and dimensional analysis, which is unit conversions. In this lesson, you will be able to view an overview of the unit. So where are we going with this unit? What does this unit even mean? Set up and calculate conversions, and practice dimensional analysis using nonsense conversions. Okay, I'm super excited. We're going to be using a Harry Potter dimensional analysis for your learning experience. I highly recommend you check that out. And Unit 6 is one of my favorite units to teach in chemistry. So Unit 6, stoichiometry overview. Where are we going? Stoichiometry is the relationship between the amounts of substances in a chemical reaction. It's a big fancy word, but that's all it means. We're figuring out the relationship between the amounts of different substances in a chemical equation. So essentially, we're going to be able to calculate how much reactant is needed or how much product will be produced in a reaction. Remember, we can do this because of the conservation of mass. To get there, we're going to take baby steps. There are a lot of new units we're going to learn, so even though the math is set up the same, learning the units and how to get there can get messy. And so my recommendations for this unit. First of all, take a deep breath. This might be challenging, even for everybody who is, speeds along with chemistry so far. You might get stopped here. And that's okay. It's okay to keep practicing and learning. So take your time to think through each step and use your resources. During your lessons, you'll have access to a map, and during your test, you'll always have an equation sheet to help. Practice. The learning assignments for this unit are important. I know many of you just use the ed puzzles and then go on to the mastery checks, but remember to pick 5 to try. If you feel good about it, attempt the mastery check. If you don't pass, try 5 more. It's really important to do the learning assignments this unit. Ask for help, okay? I can't read your mind. You need to come back into the Google Meet or stay on the Google Meet and ask questions. And don't give up. If you get a 0, if you don't reach mastery the first time or even the second or third time, keep trying. It will eventually click. It's just a pattern. Once you figure out the pattern, it will be a breeze. And also, make sure to show all of your work. Set it up the way we're going to teach you how to set it up. That way, you can easily see when your units cancel. So where are we going? Lesson 601 is to learn the setup. Lesson 602 is what is a mole and what is Avogadro's number? You can say avocado's number, but it's Avogadro's number. And we're going to learn some new units. 603, we're going to do mole to mole conversions. So we're going to convert between moles of 2 substances. 604 is molar mass. We're going to figure out how to calculate something's molar mass. Then we're going to go from moles to grams using molar mass. 606 is grams to moles using molar mass. And then we're going to use moles to particles using Avogadro's number, and particles to moles using Avogadro's number, and then moles to volume and back. So here's the map that we're going to be doing. So here is, we're going to write in moles here. Oops, where's my pen? Moles. And then over here is grams. And then over here is atoms. And over here is volume. Okay, you can use the railroad track to set up. I'm going to also show you a different way in case that doesn't work for your brain. But if you notice, the central unifying theme is moles. Moles connects every part of here to each other. And then we're going to do 610 and 611, which is stoichiometry. We're going to go from we can go from grams of one substance to grams of another substance using this highway. So what is dimensional analysis? It's a problem-solving method that uses the fact that any number can be multiplied by 1 without changing its value. So, for example, 1 inch is equal to 2.54 centimeters. We can represent this ratio because right here is it's the wrong color. Right here is a ratio. We can represent that ratio as a fraction. I should probably change that. Hold on, bear with me. So this is a ratio. Oops, that's not good either. I need to get better at circling things. And as a fraction, we're just going to leave the circle there. We can represent that ratio as a fraction. So 1 inch over 2.54 centimeters or 2.5 centimeters over 1 inch, depending on what you need it for. It doesn't change the fact that 1 inch is always equal to 2.54 centimeters. These are known as conversion factors. So write that in your notes. Conversion factors. Okay? To set up the railroad track method of unit dimensional analysis, you write what you are given here in this spot on your railroad track. Then, where do you want to go? What units do you want to end up with? Goes up top. Then, let's see. Your given units are on the bottom. So if your given units was inch, your given conversion factor is on the bottom. And then this tip from Ms. Fleischer says to look up and fill in the conversion factor after your units are set up. I typically don't do that. But if that helps you to keep everything straight, then that is a good tip to do. This is how my brain works. And this is how I was taught from 5th grade math through college, using the parentheses. And so there's the railroad track method that you can use, and then there's the parenthesis method. I use the parentheses, and I will probably use those when we do examples in live sessions, but you are more than welcome to use the railroad tracks. So what I do is my given goes here. What am I given in the problem? And it's over 1 because you can write anything over 1. I do that so you can see that the given is on the top. Then I use my conversion factor, and the units that I want is on top, and the units I'm trying to get rid of goes on the bottom. Okay, so units you want on top, units you are getting rid of on bottom. It is the exact same thing as the railroad tracks, except for instead of a line here and here, it's parentheses. It's the exact same thing. So here's an example. How many inches are in 653 centimeters? Use this conversion factor of 1 inch equals 2.54 centimeters to answer the question. So here you're going to have A, B, and C in your Edpuzzle questions. So I'm going to ask what goes in A, what goes in B, and what goes in C. Okay, to solve this using the railroad tracks, how many inches are in 653 centimeters? So my given is my A, 653 centimeters. Then here, I want inches, so my inches is going to be on top, and down here is my 2.54 centimeters because I'm using this conversion factor here. So my centimeters cancel. Just like in math, if you had x times y divided by x, your x's cancel, and you're just left with y. This is just being left with y. And when I do the math on my calculator, I am left with 653 times 1 divided by 2.54, which is 257.1 inches. So you should get, your answer should have how many inches? So that's the question. So your answer should have the inches because that's what it's asking for. Okay, example 2. Given 329.45 inches, how many centimeters are there? So in A, B, and C in your ed puzzle, you'll be asked questions about those spaces. In the interest of not making this a 20-minute video, here is the key for that using the railroad method. And here's the key using the parentheses method. Note that we get the exact same answer.